as I mentioned in the introduction, POINT was really just designed to test whether providing a significant incentive would change the way in which a teacher could approach their job and ultimately impact student test scores. And what we mean by significant incentives is prior to implementing this project, I think every program that we pretty much looked at rewarded teachers a maximum of $3,000. In this project, we set a baseline of $5,000 was the minimum, and the maximum was $15,000. It was set as a randomized control trial. We went out to middle school math teachers in September of 2006. We went through a recruitment process where trained research associates spent an entire day in schools to answer any questions that math teachers had about the program, and then they would sign up. 296 teachers, or approximately 70% of those eligible, signed up. They were then randomized into control, which is life as usual, or a treatment or bonus eligible condition, where depending upon the performance or the growth of their students during that current academic year, they could win a bonus. And we had at least one control and one treatment teacher in 38 of Metro's 40 schools, and that's in year one. At the beginning of the project, there was a significant amount of time that we had spent negotiating the design. There was many people and individuals involved, and we set a few standards that the design had to meet. One of those is that teachers would not compete against one another. Historically, teacher pay for performance programs had been set up as a fixed tournament. You could have a math teacher next to you, you're teaching math, you don't want to share your best lesson plan, because essentially that teacher could also be taking bonus money away from you. We also wanted to make sure that the awards were given at the individual level. The discussions we had emphasized that we wanted everyone to be able to elect it on their own, but we also didn't want to have a vote where if 70% said yes, then everybody has to do it, even though 30% might not have been in favor. And so we went to the individual level for the unit of accountability. We also said that teachers would be evaluated based on the progress of their students as measured by TCAP, which is the state's high-stakes assessment, and that the performance thresholds to earn a bonus weren't so high to discourage those who felt they're far away. They weren't so low that we had to spend a tremendous amount of money, and there was some gauging there, so we could do that. And then the maximum bonuses, as I said during the introduction, had to be large. At the beginning of the project as well, we took 3 years of data. We calculated using a similar strategy to how we calculated a teacher's value-added effect estimate in order to determine their bonus during the treatment years. But we did this before the experiment was even implemented. And so we were able to establish historical benchmarks that teachers had to hit in order to reach bonus status. What we found is that when we established it at the 80th percentile, a teacher would receive $5,000. If a teacher hit the 85th percentile of past performance, they would receive $10,000. And if a teacher hit the 95th percentile, they would receive $15,000. When we began the project as well, discussions seemed to suggest that most middle school math teachers only taught math. When we received the data and began to look at it, it became quite clear, particularly in 5th and 6th grade, that most taught math and something else. So we developed a bonus system that would actually adjust downward a teacher's bonus if their students in these other subjects didn't meet the average performance gain in the district that year. And that came up quite a bit as well. In the next slides, we'll show you that a few teachers had their total bonus amounts reduced. As I mentioned for the performance measure, it was going to be based upon a value-added measure from students from year to year on TCAP. The other issue that we really faced during the design phase was, should we use a simple measure or a complex measure? A complex measure is going to be a little bit more precise. A simple measure is possibly something a teacher could maybe understand a little bit better in terms of how that calculation took place. And we met with some teachers, and we came down on the side that we wanted to use a simple measure of value added. We feel as though that information could actually help with the incentive effect of the program. And in fact, a teacher could calculate that bonus themselves, in essence, if they had their students' test scores and some benchmarks. The one thing we did have to do is from the state each year, we received state benchmark gains based upon if a student had a 240 in 5th grade in 2006, we needed to know the average of that student's score the next year on the same test in math, and they averaged that across the whole state, and that became the target. So what you'll see here, and this is just hypothetical example, but this is literally what the teacher's bonus report would look like. You see on the left-hand side here a series of student names. The first score is actually going to be their prior year score, and in this particular situation, Jay Smith, who had a 250. That next year, in 2007, every student who scored a 250 on the math TCAP, on average, scored a 270. So 1 year's worth of academic growth in this instance would be 20 points. In the fourth column over, we see individual 2007 math TCAP score, which is a 285. And the next column over, it says 15. So in this instance, Jay Smith exceeded expectations of 1 year's worth of growth by 15 points, and the teacher was credited for those 15 points. We do this for every single teacher within the class. We go down, the table gets cut off, but it does average out to +7. If at the 85th percentile, for example, is about 3.7 was the 85th percentile value-added score for historical performance. What this shows here is the bonus award distribution by year. The top column is going to show you the number of treatment teachers who were in the experiment. We started in the first year with roughly 143. By the end of the experiment, there was only 84 teachers left in the treatment condition. I will note with that, in the treatment condition, only one teacher in the entire experiment asked to be removed. All other teachers either became no longer eligible because they changed grades and were no longer teaching middle schools. They no longer had 10 students in their class. That was one of the things that we always had to have at least 10 students enrolled in their math course that are expected to take the spring TCAP test. And some teachers, in fact, moved back to teaching, let's say, English for the rest of the year. You also can see that it was pretty constant across times. We range between 40 and 44 teachers receive a bonus every year. The bonuses averaged between $9,000 and $11,000. And over the course of the 3 years, we ended up spending about $1.27 million on bonuses. In terms of data collection activities, it's very important to understand that in addition to the survey data, which we have a tremendous amount of surveys that we've administered, a spring survey in year 1, a fall and spring survey in year 2, same thing in year 3. We conducted some interviews as well, but we're very fortunate to have developed a relationship with the district in order to be able to build a very comprehensive data warehouse in where historically things were siloed in different places, whether it was the professional development database or whether it was the attendance database. All these pieces we were able to pull together. We were able to track individual logons onto ThinkLink, which is a formative assessment. Teachers can log on to a site, and they're able to download and see how frequently a teacher did that. We also administered a check sheet list to math mentors, just to see the frequency with which they encountered teachers during an academic year. The other piece that became really critical in this process is just knowing, do we have the right data? Because obviously we're relying on student-teacher linkages, but do we really know what students are nested within which teachers' classrooms? Now, we thought at first, before we started digging into it, we said, sure, of course we do. We have our month-by-month course snapshots. It gets recorded. We know who they are. But to test this idea, we actually sent every single teacher a list of every single student by class that they instructed. And we asked them, go through this list. Every student on this list should be continuously enrolled in your class from the 20th day of school until the day of TCAP testing, and if you don't think it meets that, let us know. What you see is we created about 143 teacher rosters in the first year. That's the top row up here. In the first year, 55 teachers came back with appeals. The appeals process was then turned over to a district staff member who was able to go through a series of data that we didn't have access to in order to confirm what happened, or even to reach out to school site-based individuals who were handling the data issues. Sometimes we didn't approve those changes. The good news is that over time, the information systems greatly improved in the district, but there were instances where whole classes weren't being represented. So if we go into a performance management, or if we go into a pay for performance program, or if we make high stakes personnel decisions based upon the linkages that are not validated, we might not even be making the right decision just because the data is inaccurate. In terms of findings, we're going to skip to findings. We're not going to go through the methods piece, and there's some other things that we can talk about in terms of threats to validity, but we'll open that up when we have our questions as a team here. We don't find a significant difference overall in mathematics test scores between students whose teachers were assigned to the control group and teachers who were assigned to the treatment group. We do not see any significant differences when we look at the effect by grade, 6, 7, 8. We do find a positive effect in grade 5 in years 2 and 3 of the experiment, and it ranged from about 1/2 to 2/3 a year's worth of typical mathematics growth, which is quite large. However, we don't see this effect persist when the 5th grader goes on to 6th grade. That we no longer see the difference. The one caveat here is that we still don't have the data from this most current year, so it's just for that one cohort, and we'll go back and look into this to see if it's different. Now, some people may be quickly raising their head going, was there cheating, or was there something else going on? We did a suspicious answer string analysis. Every year we looked at the percentage of types of students going between classrooms, were students excluded on test day. And none of the typical things that we know about in the literature came up to suggest even close to any type of opportunistic behavior. So, given this lack of persistence in the finding, we don't quite know how much weight to put on it. And we can also talk a little bit about some of the additional tests that we did to further explore what is happening in 5th grade, looking at the proportion of teachers who instruct all students, or what percentage of their students, and so forth. In terms of teacher attitudes, there's few significant differences on the surveys in terms of teacher attitudes, beliefs, practices, and perceptions of the school environment when we compare the treatment and control teachers. For the most part, the control and treatment teachers' responses didn't change over time, although teachers were generally supportive of the program itself. Roughly 80% of all teachers in the treatment group said that they had been working as hard as they're already working as hard as they could, and that the bonus would not affect their behavior. With that said, we'll open up for questions. Hopefully there'll be many questions to ask, but thank you.